Hello students, how are you? Uh, it's nice. I have received so many questions from you that I had to think for some time how to give the solution of all the questions in one video or one or two videos. Adjusting was tough, and the reason was not that the questions were tough, but the reason is like what questions you are asking that I have not explained already. So we have to proceed with the theory explanations. Along with that, I'll be taking up some of your questions. Okay, very good questions. Charles, we'll discuss two things: quantization of electric charge, and second point we'll discuss is the principle of a superposition. Principle of a superposition. So depending on quantization of electric charge and the principle of superpositions, we can get some numericals also, and we will be covering few numericals as well. So what is quantization of a charge? Quantization of anything. What do we mean by quantization of a something? We'll understand that first, then we'll extend that idea to quantization of a charge. Suppose we are having a block of mass m, let us say, and suppose you divide it into two parts, let us say two parts, it become two parts, and whatever parts is coming, again you divided that into two parts, let us say whatever part is given, again you divide into that two parts, whatever small part is coming, again you divided that into two parts. If we will go on dividing further dividing, a point may come where the final particle or final quantity may not be divided further, and in whichever quantity this happens, what happens, the phenomenon happens where a final quantity comes which cannot be further divided, is called quantization. In that sense, mass is not quantized, or even if it is quantized, it is not known till now, but charge is quantized. That means if we will go on dividing a charge instead of a mass, we'll divide further, divide. At some point, one small charge will come which will be equal to 1.6 into 10 to the power minus 19 coulomb, and in nature it cannot be further divided. In nature, no charge, isolated charge is found which will be less than this value. So the final smallest unit of a charge is this much only. For that we have given a symbol E. Why? Because from chemistry we know electrons, protons, neutrons, all these particles are there, right? In one atom there is one a nucleus at the center, and the electrons are revolving around the nucleus. We have learned all those things. That electron contains a charge which is equal to 1.6 into 10 to the minus 19 coulomb. And in nature till now, nothing has been found which can be having a charge less than this. Now, if from YouTube videos, etc., if you are doing some investigation kind of thing, or you are some scientists are talking about quarks and all, then there are three quarks, and each quark is having E by 3 charge or a 2E by 3 charge. These things you might have heard from somewhere, but remember that these charges are never found isolated. Means all these charges will be together only. So these are never found isolated. So the lowest possible charge found in nature is only this much, and in short we call that E, charge of an electron. And the charge of a proton is a plus this much, and the charge of an electron is a minus this much. So whatever, whether plus or minus, whatever is the nature of the charge, but the magnitude will be 1.6 into 10 to the minus 19 coulomb only. So if there is a charge somewhere, a charge is given to some mass, there is a charge, let us say charge is a Q, charge is given. So how much a charge can be there inside that Q? that Q must be equal to N times E. The charge must be equal to an integral multiple of the minimum possible charge. Integral multiple, that means this multiple n has to be one integer where n is equal to 1 or 2 or 3 and so on. It cannot be 1.5 Ne or 0.5 Ne or a 2 by 3 Ne. It is 2 by 3 E, 1.5 E, 4.5 E, some fraction. N can never be a fraction. It must be one integer. So Q is equal to plus or minus Ne. But this E can be plus also, minus also. So if we are writing this plus or minus Ne, this Q is equal to plus or minus Ne is the mathematical expression of quantization of the electric charge. Clear? Quantization of electric charge. Related to this, in your assignment, you will find one question: what is quantization of a charge? That's fine. Why is it meaningless at a macroscopic level? This also is an important repeatedly coming question in exams. It is very simple. See, suppose you are having 10 crore rupees, let us say. So 10 to the power 7 rupees you are having. Now, you spend 1 rupee or somebody is giving you 1 rupee. Does that matter to you? No, right? Your perspective is you are thinking of 1 crore, or let us say some 5 crores or 10 crores you are having, and then 1 rupee doesn't matter for you. The reason is 1 rupee is too small as compared to this figure. It is just like that. Now, if we say some 1 coulomb of a charge, how many electrons are present in 1 coulomb of a charge? If this is the question, total charge Q divided by the charge of the smallest charge. If the smallest charge E, how many E, these many charges are present here? That we can calculate. Now, let us say what it is saying, macroscopic. All macroscopic charges, is it visible? I am erasing something, some area just to manage it. Now, one electron is equal to 1.6 into 10 to the power minus 19 coulomb. Q is equal to Ne, then N is equal to charge by E. From here, yes or no? So, how many number of electrons are present in 1 coulomb? N is equal to 1 divided by 1.6 into 10 to the power minus 19. Now, in macroscopic level, charges are in terms of microcoulombs. So 1 microcoulomb, 2 microcoulomb, 1.5 microcoulomb, it is something like that in terms of microcoulomb only. So into 10 to the power minus 6. Micro, you know, right? Coulomb, microcoulomb means 10 to the power minus 6 coulomb. This you know, SI system, right? Microcoulomb means 10 to the power minus 6 coulombs. Now, in this, in 1 microcoulomb, how many electrons are there? If we calculate like this, Q by E, then how many? 25 into 10 to the power 12. 6.25 into 10 to the power 12. Do you realize how big this number is? 6, after that 12 zeros. 625, 625, and after that 10 zeros. 10 zeros. If a so huge number of electrons consists of to make 1 microcoulomb only, then some electrons go this side or that side. How does that matter? Charge of the body, which is having some, let us say 2 microcoulomb charges or 5 microcoulomb charges, few electrons if will be moving from here and there, that doesn't matter at all. Do you understand? So that is the answer to this question, that why charge is, quantization of a charge is meaningless at a macroscopic level. Got it, right? Now we will go to the idea or the theory of the superposition principle, or principle of superposition in electricity, and depending on both these concepts, we will be taking up some numericals. The second topic is the principle of a superposition. We have understood very nicely how the Coulomb's law of electricity governs the force between two static charges. So let us say there is a charge Q1 and let us say there is a charge Q2 separated by a distance R. Then the force experienced, the force of attraction or repulsion. Instead of saying always attraction or repulsion, let us assume that all are positive charges. So this is force of a repulsion only. So this force is given by 1 by 4 pi epsilon naught Q1, Q2, that the product of the two charges divided by the square of the distance between them. This is in short the Coulomb's law. Yes or no? Now, in superposition, instead of only two charges, if there are multiple charges, let us say here there is another charge which is Q3, here there is another charge which is Q4, here there is another charge which is Q5, let us say, and okay, let us say there is a point P. Here let us say there is plus 1 charge is there. Whenever at a particular point we want to learn the forces, some charge only will be repelled or attracted by them. So that charge, it is customary to assume that there is one unit positive charge is there, like that we assume it. Okay, so at P, what is the force experienced due to Q1? So if I join Q1, so this is plus and this is plus, so it will be repulsive in nature, right? This will be the force on P due to Q1, yes or no? Then what is the force on P due to Q2? See, if only Q1 was there, this is the force that we understood from Coulomb's law, and we can calculate the magnitude of that also, and that is equal to 1 by 4 pi epsilon naught Q1 multiplied by 1 by distance between them whole square. Let us say this R1 is the distance between Q1 and P, so R1 square. Got or no? Now, what is the force on P due to Q2? So this also we can calculate along Q2. This is a repulsive, so P experiences a force away from Q2. So let us say this is the force on P due to Q2, and what we can calculate that? Again, I'm not writing here to make it complicated, but what is that? 1 by 4 pi epsilon naught Q2 into plus 1. So Q2 by square of the distance between them. Let us say the distance between P and Q2 is R2. So R2 square. So here if I am writing FP Q1 is equal to 1 by 4 pi epsilon naught Q1 by R1 square. FPQ2 is equal to 1 by 4 pi epsilon naught Q1 Q2 by R2 square. Similarly, due to Q3, along this line, Q3 is a positive, all are positive charges we assume, right? So Q3 is positive, P is positive, so positive will be repelled. So the unit positive charge at P will be repelled by Q3, right? So this is, let us say, force on P due to Q3. So force on P due to Q3 is equal to, according to Coulomb's law again, 1 by 4 pi epsilon naught Q3 into 1, Q3 by R3. Let us say R3 is the distance between P and Q3. So R3 square. And you understood the concept, right? So why to take another Q5? Let us 4 charges are there. So again, joining P to Q4 like that. Force on P due to Q4 is equal to 1 by 4 pi epsilon naught Q4 by R4. Is it fine? Now the principle of superposition or superposition principle says that the total force experienced by P is equal to the vector sum of all the forces acting on P due to all the individual charges placed around. Fine. So now you tell me force is a scalar quantity or a vector quantity? It is a vector quantity. That is why if many vectors are there acting, the resultant vector must be a vector sum. It's not algebraic sum. Is it clear? Now if we'll add all vectorially, so 1 by 4 pi epsilon will, so therefore F net, I am writing net force is equal to 1 I square, I is equal to 1 to N. If there are n number of charges, I equal to 1 to N, just we go on adding. So this is the principle of a superposition. So now we are going to discuss certain numericals which you have asked, and basically I am taking up only those numericals which are based on these two concepts what we have learned just now. Okay, so one question from quantization of a charge says two objects P and Q carry charges minus 3.00 microcoulomb and minus 0.44 microcoulomb. What is the number of electrons transferred from P to Q so that they acquire equal charges? Okay, while discussing this, I am discussing one hypothetical concept. Let us say there are two trees. Okay, and there are some birds, few birds are sitting in a tree A, let us say, and there are few birds sitting in tree B, let us say. This kind of simple arithmetic you might have done in your earlier classes in your childhood. Okay, now here let us say there are 7 number of birds are sitting, here 6 number of birds are sitting on the tree B. Now how many birds should fly from tree A to tree B so that both the trees have equal number of birds? So by common sense, you might have said that if one flies, so let us say at one tree, in tree B there are 5 birds, in tree A there are 7 birds. Then from common sense we can say that if one flies, this also becomes 6 and this also becomes 6, so both become equal. Fine. But what is the mathematical aspect of that? What we did actually is when both become equal, then it will be average of the two. We found out this is equal to 6. Now to be 6, how much A has to lose, or how many birds must fly from A to B? So we found out the gap. 6, 7 were there. Now it has to be 6. So one bird has to fly. Now this question is just like that, but since it is very simple numerical, simple integers, it was also you could find without applying this idea also, just from common sense you found out. But in this case what it says is there is P, there is Q, like a P, Q. Here two trees like that. In this question what it is given, and did you see the similarity? In this question what it says is there are two objects P and Q. What it says is they carry charges minus 3.00 microcoulomb and Q carries minus 0.44 microcoulomb. What is the number of electrons that should be transferred from P to Q so that both of them acquire equal charges? Then just like that example, we will find out the average of these two. So minus 3.00 plus of minus, so minus only, right? Plus of minus is minus only, 0.44 microcoulomb divided by 2. So what is the average? Minus 3.44 by 2, that is equal to minus 1.72 microcoulomb, right? Because both were in microcoulomb. So when both are having equal charges, then each one will be having a charge equal to 1.72 microcoulomb. Now currently P is having a charge of minus 3 microcoulomb, and in it has to be having a charge of minus 1.72 microcoulomb. So what's the gap between them? Find out. What's the gap? Minus 3.00 minus of minus, so this become plus, right? 1.72 microcoulomb. So this is equal to minus 3 plus 1.72 is equal to how many? Find out. In class you could have done that. Now I have to do the calculation part also. Okay, so minus 3 1.72 plus, so this will minus 1 comes 8 and 2 1, so minus 1.28 microcoulomb. this much charge has to be transferred from P to Q so that both will be having equal charges. Is it clear till now? But the question is how many electrons has to be transferred. What we found out is how much charge has to be transferred, right? So that's true, this much charge has to be transferred, but in this much charge how many electrons are there? That is the question, right? So therefore number of electrons transferred from P is equal to 1 minus 1.28 microcoulomb into 10 to the minus 6 coulomb divided by, what is the charge of one electron? Minus 1.6 into 10 to the power minus 19 coulomb. And this answer you calculate yourself. I calculate somewhere. It is coming 8 into 10 to the power 12 number of electrons. Okay, so these many electrons if is getting transferred, that is equivalent to minus 1.28 microcoulomb of a charge, and if a minus 1.28 microcoulomb of a charge is transferred from P to Q, both of them will acquire equal amount of a charge. Is it clear? Question number 7, which says the two equal positive charges each of a 2 microcoulomb interact with a third positive charge of a 3 microcoulomb situated as shown in the figure. There is a figure given. A is having 2 microcoulomb charge. There is B, which is having another 2 microcoulomb charge. Both are positive, it is saying. So plus, let us write 2 microcoulomb. This also is a plus 2 microcoulomb charge. And the summit point O. In the question it's given this to be 3 meter. And this side also is a 3 meter. And there's a point P along this line. There is some point. There's a point P at a distance of 4 meter from O. Okay. Calculate the magnitude and direction of the force on the 3 microcoulomb charge. So we have to find out the force experienced here by P, where a plus 3 microcoulomb charge is present at this point. So what is the force experienced by P due to A and B is the question in short, right? Which is due to one charge is a simple Coulomb's law, and due to both the charges together we have to apply the principle of a superposition. Now what we'll do, what is the force experienced on P due to A we'll calculate, what is the force experienced on P due to B we'll calculate, and we'll find the resultant of those two components. Now see, what is the force experienced by P due to A? This is plus plus, so it will be repulsive in nature, right? So this is FPA, let us say. Now what is the force experienced by the plus 3 microcoulomb which is placed at P due to B? Let us say that is FPB. Now see, considering in the triangle, OAP, it's a right angle triangle, right? We can apply the Pythagoras theorem here. This side is 3 meter, this side is 4 meter, and this side must be 5 meter. AP is equal to root under 3 square plus 4 square is equal to 5. So this is 5 meter. Similarly, in the triangle OPB, also we can find out PB also is equal to 5 meter, right? That's why, what is FPA? According to Coulomb's law, FPA is equal to 1 by 4 pi epsilon naught Q1 Q2, 2 microcoulomb into 3 microcoulomb. So 2 into 3 into microcoulomb, 10 to the minus 6 into 10 to the minus 6. So 10 to the minus 12 divided by R square, 5 square, that is 25, right? Similarly, FPB is equal to what? 1 by 4 pi epsilon naught q1 q2. Again 2 into 3, the same thing only comes, right? This also is plus, this also is plus, q1 q2 by r square. R also is same, so exactly the magnitude is same only the directions are different, but magnitude is again 1 by 4 pi epsilon naught q1 q2, 2 into 3 into 10 to the minus 12 divided by r square. That's 25. So FPA is equal to FPB. Magnitudes are same. So what we can write, FPA is equal to FPB is equal to FSA. So magnitude is same. Now see, if this is theta, this also is theta, yes or no? 3 meter, 3 meter. And if this is theta, this is theta, and this is theta, opposite angle, this also is theta. Now FPA, which is equal to F only, can be resolved into two components, yes or no? Now horizontal component will be F cos theta, and vertical component will be F sin theta. I'm not writing that, that is okay, let me write it, F sin theta. This F also can be resolved into two components. One is F cos theta and F sin theta. See, for FPB also I am considering F only, and FPA also I am considering F only. Clear? So now see, F sin theta, F sin theta, these are equal in magnitude and opposite in direction. That's why they will be cancelled out by each other, yes or no? Fine. But the F cos theta component got added up. So what is the total force experienced by P? It is 2F cos theta plus F cos theta, 2F cos theta along a PX. So therefore I am writing F net is equal to 2F cos theta along Px. Yes or no? Is it clear to everybody? Now the matter is just a calculation. This is equal to 2 and F is equal to how much? 1 by 4 pi epsilon naught q1 q2. What is that, right? 2 into 3 into 10 to the power minus 12 q1 q2 by r square, 5 square, that is 25, 5 into 5. So 2f cos theta, and what is cos theta in the triangle OAP? Let us say cos theta is equal to b by h, 4 by 5. For cos theta I am writing 4 by 5. Got? So this is coming the final answer when you solve this much. For 1 by 4 pi epsilon naught, what you will put? That we have already done in the previous sessions, right? 1 by, wherever 1 by 4 pi epsilon naught comes, we can put directly 9 into 10 to the 9 there. And the final answer comes, this much is equal to 3.5 into 10 to the power minus 3 Newton along Px. That is the final answer. Is it clear by everybody? Now see, there may be complicated questions like instead of two charges, there may be 3-4 charges at various places, and it can be asked to find out the resultant, and that also will be one application of a principle of a superposition. Now from various books etc., you can take up many questions, and if you are not trying various books also, I have given the assignments. From the assignments, whatever questions are there, you pick up them first. So thank you.